So the way I've laid this out now, all of the PowerPoint slides are going to be behind this card here, and all of the labs are going to be behind this card. So, if I just go into any one of them, this is going to grow, obviously, as we work our way through the various topics. So the first lab is to do with TypeScript. I noticed actually from some interaction that I had with students yesterday and the day before, I didn't actually intend you to start working on this lab this week because I need to cover some of the aspects of TypeScript before you can do the lab. But after today's lecture, you will be able to work your way through, not all of it though. It depends on how far I get in my coverage of TypeScript as to how far you can go in the lab. But maybe I'll come back to that at the end of the lecture. I'll know better than how much progress I make. Behind this card here is where I'm going to put all of the PowerPoint slides. So I've laid it out slightly differently to the way I would have laid out the web app dev last year, but you'll get used to it. So let's get straight into the first set of slides, which are these ones here. There's also an archive accompanying this set of slides, and you'll get it from here. So if you click on this card, it'll download a zip file, and you're expected to unzip it and then import it into VS Code. And I'll talk about the contents of that maybe in a few minutes. So let's work our way through the slides. Now, somebody was asking me yesterday, and it was a reasonable question as to why I'm using TypeScript. We could really have used any language. The main focus of this module is AWS and infrastructure as code and all those other good things that I mentioned in the kind of overview that I gave you during the week. We could have picked any language. You could have picked JavaScript, Python, Java, Go, etc., etc. There are a number of other ones, but it was kind of an arbitrary decision that I decided to pick TypeScript. I do know that you have a lot of JavaScript, so it was kind of linked to that as much as anything, really. But if somebody else was teaching this module and wanted to teach the same material but didn't want to use TypeScript, then they could pick another language and it would all work. The material that I want to cover could as well be taught through another language. So it's somewhat arbitrary. But I have chosen TypeScript. So let's see. Now I need to remove something from my screen, so just bear with me. So if you read anything about TypeScript, you know that essentially it is a superset of JavaScript. In other words, all JavaScript is automatically TypeScript. And what TypeScript does, in addition to vanilla JavaScript, is it adds a type system to your language. You might remember from last year, I would have said that JavaScript is a dynamically typed language. Well, TypeScript is a statically typed language. It imposes types on your various variables for good reason. Now, it's the good people of Microsoft that designed this language, and it was designed by the same person that designed C# and Turbo Pascal, Anders Herzberg, if that's how you pronounce it, I'm not sure. So it's got an excellent pedigree, really, when you think of those other languages and their popularity. Now, I'm saying there it dates back to around 2010, 2012. I think the first release of TypeScript was 2012. And it's obviously based on JavaScript, but it was based on two specific ECMAScript specifications. You might remember ECMAScript is this specification for the JavaScript language, and the ECMAScript specification kind of evolves over time. ECMAScript 4 dates way back to the early noughties. ECMAScript 6 is around 2015, I think. Now, oddly enough, ECMAScript 4, that version of the ECMAScript specification, it was never actually followed through. It was kind of abandoned. And what ECMAScript 4 tried to do was to introduce a type system into the JavaScript language. But I guess the community didn't really buy into it. But it has found its niche now, really, under the title of TypeScript. So, oh yeah, so I'm saying here that, essentially all JavaScript is automatically TypeScript. But what TypeScript does is it adds a typing system, as I've already said. It adds a typing, I'm saying here, it adds the structured type system of ECMAScript 4 into JavaScript. Sorry now. And where it really shines is if you're developing large application, if your application code is really large, that's where TypeScript really shines, as opposed to JavaScript, as an alternative to JavaScript. And it's fair to say that today really there's very, very little new software being developed in the web world which is using JavaScript. They're pretty much all using TypeScript. And on the next slide here, I'm showing you how the TypeScript language has grown in popularity. It's still a really a relatively young language, I suppose you could say. But you can see there it really rocketed into popularity around 2016 or so. And as I mentioned there a moment ago, any new web-based development, i.e. JavaScript-based development, or what would have been developed in JavaScript, is now really being developed in TypeScript. So we could well have taught the web app dev module last year in TypeScript, because that's really what the industry is using, as opposed to JavaScript, mainly because of this typing system that has been layered on top of JavaScript, if you like. And the great thing about having a type system is that it makes your code more predictable, safer, less error prone. That's really what it's all about. If you remember last year, we all came across this problem of accessing undefined variables. Really what TypeScript tries to do is eliminate those errors occurring in your code. And it catches them at compile time. TypeScript is a compiled language. If I could just go back to the previous slide, I'm not sure if I'm mentioning it there, but TypeScript is a compiled language, and what it compiles to is JavaScript. So you're always falling back to JavaScript even when you're using TypeScript. JavaScript is the runtime version of your code. TypeScript is just a compile time version of your code. The file extensions that we use are .ts for source code, and there's also these .d.ts files, and it's in these declarative or declaration files. This is where we can define the various data types that make up our application source code. They're a bit like header files, if you're familiar with header files in the C and C++ world. We'll see examples of them in a while. What am I also saying there? Now, where these declaration source files, these .d.ts files, where they are also used is in existing JavaScript third-party libraries. You see, when you're writing TypeScript, you would like to avail of all of the JavaScript third-party libraries that have been developed over the years. You'd still like to avail of those in your TypeScript code. And so what the third-party library creators did was they added these declaration source files to their JavaScript third-party libraries to enable us to use them in our TypeScript code. Because what these declaration source files do is they essentially tell us what data types are being used within your JavaScript third-party library. And they're excellent as well. They come into play when we're using IDEs or editors. They provide all the kind of hinting and intelligence to us, as we'll see in a while. So we mainly write .ts files, but we can also have .d.ts files in our source code. In terms of fundamentals, obviously, any language has primitives, and TypeScript's primitives are, as you would expect. So it has the number primitive, Boolean primitive, strings, null, and undefined. So it's still retaining that undefined from JavaScript. So we can still come across that issue, but we try and minimize the occurrence of it. TypeScript helps us to minimize the occurrence of it in terms of runtime anyway. And apart from primitives, then it has a whole object type, object in the generic sense now. So objects encompass classes, methods, interfaces. So you know what interfaces are from your Java background. Well, interfaces are available to us now in TypeScript. They're actually available in JavaScript as well, because they're a part of that ES6 or 7 ECMAScript specification. And we have literal types as well, as we'll see in a while. TypeScript also supports typed arrays, which is a really nice thing. That was one of the weaknesses of JavaScript. An array in JavaScript could have a mixture of different data types within it. But now we can impose more structure on our arrays by declaring them as only allowing certain particular values of a particular type to be within an array. There's this odd one as well. There's this any type. TypeScript's type hierarchy at the very top of the hierarchy is the any type. So you could have a variable and its type could be the any type, which really means it can hold any type of value. Now it's something we try to avoid at all costs if possible. But there is this notion of really if a TypeScript variable's type is the any type, then we're really back in the JavaScript world. You might remember when I introduced JavaScript to you, I said that when you declare a JavaScript library, a JavaScript variable, you can assign any value of any type to that variable. Hence, it's a dynamically typed system. Now, TypeScript tries to remove that flexibility by imposing a type system, but you can always fall back to that JavaScript world by declaring a variable as being of the any type. You would want to minimize the use of that now, but it's still available to you, I suppose, so to speak. Okay, let's see some TypeScript code. So the first thing that we need to know about TypeScript is how do we actually declare the type associated with a variable? When we declare a variable, and we declare it the same way we do with JavaScript, we use the let and const keywords, but you add on this suffix onto the variable name, and the suffix, I'm calling it a postfix here. The postfix comprises of a colon and the type name. So if you see the simple example here, I'm declaring a variable called me, and I'm saying its type is the string type, which is one of the primitives that come with the language. And indeed, I am assigning it a string. So if I flip over to the archive, now I mentioned there earlier on the lecture that in the website, if you click on this card here, that will download a zip file. And if you unzip it and import it into VS Code, what you will get is the following. You get this here. And we need to kind of work our way through the various examples that I want to show you. So if we start off with the 00 basics folder inside in our source folder, by the way, this is an NPM project. You can see a package.json there. So you have to run npm install after you've imported it into VS Code. I think I mentioned that in the README file anyway, because we're still leveraging all that NPM ecosystem, if you like. So I've ran npm install already, and in fact, if I just jump into the README. So you run npm install, and if you want to execute any of your TypeScript source code files, this is the command to do it. Essentially, what you're doing is, what this command does is it takes the TypeScript file that you provide here, it compiles it using the TypeScript compiler, because TypeScript is a compiled language. It compiles it into JavaScript, and then it runs that JavaScript code on top of the Node platform. So we're always, we haven't abandoned all of that JavaScript stuff. It's still there available to us. So it's npx as opposed to npm, npx ts-node, and then the name of your TypeScript file. So let's look at our first TypeScript file. And here we go, some examples. Here we're declaring a variable of type string, and we're assigning it, we are indeed assigning it a string. Now, when you're doing any TypeScript development inside in VS Code, the really important tab to keep an eye on, or the really important panel to keep an eye on, is this one here, the problems panel. Because what happens behind the scenes is, as you're actually typing your source code, the TypeScript compiler is constantly checking your code as you're typing, and it will warn you, prompt you of any errors that are in your TypeScript code, and you'll see those warnings appear down here in the problems panel. So if I give you an example, supposing I decide, it wouldn't be very intelligent, if I decide I want to assign the value 10, which is a numeric value, to a variable that I've declared as a string. And straight away, not only the bold kind of underline tells me there's a problem in that statement, and it's telling you what the actual problem is down here. So that's our very first indication of the fact that there is there's some sort of type constraints on our variables. Yeah, okay. I won't labor the point. As you can remember from last year in JavaScript, if I declare a variable and assign it a string, and then on the very next line I assign a number to that same variable, then that's not going to be a problem from JavaScript's point of view. So this postfix, this is how annotation, this is how we declare a variable's type. Here's another example where I'm declaring a number variable, and I'm indeed assigning it a number value. And once you declare the type for that variable, you can never change that variable's type from there on in. So I cannot go down here. I can't go my string. Let's say equal to the Boolean true. Doesn't like that. And it's telling you down here, you can't assign a Boolean value to a string variable. So it's very, okay, this is kind of 101 stuff, but you're getting the essence now of what TypeScript is. It's a, it enforces typing on your variables. Oh yeah, well that line there is, if I enable that line, then I'm going to get an error because I'm assigning a string to a number. So we've already made that point. What's also nice now is, now that this is declared as a string, then the various kind of methods that you might be able to invoke on that string, they will become available to you in terms of hinting. So if I go, for example, let x equals my string, and I want to get the length of it, then, well, it's giving me a couple of options, LE. It's hinting to me as to what I might want to actually type. If I can't do something silly like len, let's say I've forgotten that it's actually length rather than len, and it's going to give me, is it going to give me an error? Yeah, it's telling me, look down here, that there is no property called len on the myString variable. Oh yeah, so there's hinting available to us Boolean. That's okay. It's just another example. In terms of the kind of error checking that goes on. Whereas up here, when I declared a number variable, it made sense to carry out that kind of operation on a number variable. But down here, I'm illustrating, I've declared a Boolean variable. And, if I try and do something silly like that on a Boolean variable, telling me, you can't do a +1 on a Boolean. But in JavaScript, you can do that. It won't give you, well, there is no compilation in JavaScript, as we know. And even when we run it, it may actually try and perform that operation, may not actually throw an exception. Eventually, it will cause an exception. But it's not really until runtime that we and then start debugging our error and working our way back, and then finding, we try to do this to a Boolean in our code. We have to actually go through all that drudgery of running the code, getting our exception, trying to work our way back to debug it, etc., etc. Whereas here, you're told straight away at source code level, as you're typing the code, that it's stopping you, it's preventing you from doing something that you really shouldn't be doing. Typed arrays. Now, the syntax for declaring a typed array is looks like this. So here I'm declaring an array of numbers. So you just follow the type with the kind of subscript notation. And that's telling us that this thing is an array of values of this type. And equally, if we try and put a value into this array that isn't a number, then we're going to get that error appearing at the source code level before we ever have to go executing it. We have examples of arrays going on here somewhere. Thought I had. Oh yeah, there we go. And if you try and say put in a Boolean false, again, it's telling you straight away, shouldn't be doing that. There is an alternative syntax, this syntax here, where you're using the kind of angle brackets and the type is inside the angle brackets. That syntax we will come across later on. It's referred to as generics. But essentially, what we're declaring here is an array of strings. So equally up here, I could have done array. Okay, both syntaxes work. I think we would mainly use the earlier syntax when we were declaring arrays, but the other syntax is available to us. And as I say, that other syntax is really opening up another area of TypeScript called generics, which we'll see later on. Okay, so that's the 101 of type annotations. Down here at the bottom, I'm saying that this type annotations also relate to functions. So the example here, I'm declaring a function and I'm stating what type the parameters to that function are. And this is something that we are required to do as well in TypeScript. We'll come back to functions in more detail in a while. There are obviously classes are supported, but really classes came in to JavaScript in ECMAScript 6, and they were just carried forward into TypeScript. And I'm showing you on the right there just an example of the syntax of declaring classes. So I don't need to talk my way through that. I think it looks very like how you would do it in Java, for example, and it has all of the attributes of classes that you get in other languages, like having public and private methods, having public and private instance variables, having a constructor, etc., etc. Also, you have inheritance. So you can see an example of inheritance here, and we're using the extends keyword to indicate that, which again, you would be familiar with from the Java world. Here I'm saying it only supports single parent inheritance. Some languages support multi-parent inheritance, but not in the case of TypeScript. And you also have this special super variable. If you want, in a subordinate class, if you want to refer to a method of its superclass, you can use the super keyword to do that. I think you have an example of it over here, right? So you can look at that code yourselves later on, but it's there are no surprises there. Also, you'll be familiar with interfaces from, I keep referring to Java because I think that's the language you would be most familiar with. But interfaces are also supported in TypeScript and indeed in JavaScript. And you remember that an interface is where you simply declare a set of methods that you want classes to implement. So you first of all declare the set of methods in the interface construct, and then you declare that a particular class implements that interface. And I'm not going to go explaining interfaces to you because you're already familiar with them. Unlike inheritance, you can TypeScript supports multiple. You can implement multiple interfaces. A particular class can implement multiple interfaces. Now, to be honest, we won't be doing an awful lot of class-based programming in our TypeScript. It'll be mainly kind of function-orientated, with one exception, but it's available to you anyway in the language. Now, what is new, though, are unique, I suppose, to TypeScript as opposed to other languages that you've already seen, is this notion of interface data types. It's unfortunate they use the word interface because it's kind of confusing with the interfaces associated with classes. But what an interface data type there is, it tells this, it tells the TypeScript compiler about the property names of an object. So these interface data types are what you would associate with an object structure. You remember objects from your JavaScript studies, okay? Now, what interface data types allow us to do is to state a structure for an object, and then to impose that structure on instances of objects. And the interface data type will say what names the various properties are allowed and the values for those properties. So an interface, I'm saying there, is a type associated with an object structure. And here we go. Here's an example. Here's the syntax for declaring these interface data types. So I'm declaring a person type, and I'm saying this person type, it has two properties. The keys are first and last, and the types for those keys, in this case, are both strings. They can be other primitive types, or indeed, the types could be other interface types. So we know that you can have nested objects in JavaScript. Well, equally, you can have nested object structures in TypeScript. Let's see an example of that. So down here, then, I'm saying I'm declaring a variable called me, and now this variable, its type is my custom type, my person custom type, as opposed to any of the primitive types. And what the effect of declaring it as being of a person type means that this object here can only have keys first and last, and those keys, the values associated with them, have to be strings. And the TypeScript compiler will complain if you try and violate essentially this constraint that you're putting on the variable. So let's switch over to the sample code. So here we go. And really where this kind of shines is, let's supposing I just for the moment take out all of this stuff here. Where TypeScript really shines is when, as you're writing your code, it's really hinting to you what you should be doing and complaining to you if you're doing something that you shouldn't be. So what I mean by that here is, okay, I've declared a variable called me and its type is person. And I start creating my object. And if I see the way it's telling me straight away, maybe this is what you should be typing here, rather than me having to try to remember what is the structure of a person interface. Okay, it's right above me in the screen, but usually that would be declared in a different file, in a .d.ts file. I'm not using those declaration source files. I'm not using them at the moment. I'm just declaring the types locally. And so, okay, I take that and I accept it. And then if I start trying to assign something other than what should be, it should be, then it's going to complain as well. So, if I start doing this, it's complaining, and I've collapsed the problems tab, but again, that will tell you exactly where you're going wrong. So it's this IntelliSense that's it's where it really it's where you benefit as a developer, and it avoids you making silly mistakes, which otherwise, if you were doing this in JavaScript, you wouldn't discover the mistakes that you had made until you actually ran the code, and then you have to go back and do your make your corrections. Here, you're being hinted straight away. Equally, if I try and add a property that doesn't exist, it's going to complain as well. So if I start typing in address, it's telling me straight away, it's noticing that's not a valid property based on your interface data type for the person custom type. And it's telling me that at compile time. So do all of that. Now, what it does mean is, whereas in JavaScript, objects are can be expanded on and properties can be removed at runtime, you can't do that in TypeScript. So, for example, if I try and add an address property to my me object, then it's going to complain to me that I can't do that because that's not in adherence with the interface data type for person. Got another example here. Let's look at the other examples. I've got a student, got 3 properties. Here's one instance of that. It's fine. That's adhering to the interface type. Plus, the only mildly interesting thing is that I've got a property that's an array of strings. And my array, this is an array of strings. And equally, if I try and put something other than a string into that array, it's going to complain straight away at compile time, compiling behind the scenes. I've got another example. I've got a results interface type, 2 properties. I've got a student profile interface type, and here I'm using another custom type within this interface. Okay, so the type for, or the properties of the object that I assign here have to adhere to the results structure that I've defined up here. And again, it will complain if you try and violate that, or if you try to violate it. So here's some examples. Now it's fine, I guess I've already shown you that it's checking these things as you type. That's really where TypeScript, I think, is worthwhile. So I think if I enable that now, it's going to complain. Is it? Why would it complain? Oh yeah, I'm using the wrong. It should be module name rather than name. If I enable that, complaining, it says name is not a valid property of the results type. And when you're dealing, in a very large code base, it can be difficult to remember the structure of all the various interface data types, because you will have many interface data types in a large application. So trying to remember the structure of those data types can be difficult. So that's where the compiler helps you. So that's interface data types, the 101 of it. Next, we move on to type aliases. Now, there is an overlap between the notion of type aliases and interface data types. I'm not 100% sure, and I've read up on it a little bit as to why the TypeScript designers not so much introduced type aliases, because type aliases, as we'll see, are much broader than interface data types. There are things that you can do with the type aliases syntax that you cannot do with interfaces, but there is an overlap between them. And so if I just fast forward to essentially these type aliases, they again allow you to create your own custom types for your particular application. And that's really what interface data types do as well. So even from a definition of what they both are, they seem to be covering the same ground. So if we look at some of the samples here in the screenshot, and if we look at this one here, let's see, this one here, yeah. So I'm declaring a type called point, and it looks like it's a structure for an object, and I'm giving property names and property types. Now that's really the exact same as an interface, and there's no getting away from it. They are the same. There is a slight difference, by the way, in the syntax. You can see here I'm saying type interface equals and then the structure. And if I go back to the previous, there's no equals. There's no equals symbol between person and the beginning of the structure, whereas there is in type. That's only just a minor thing, but that is really the exact same as an interface, and they're used interchangeably. Now, what you can do with these type aliases, though, which you cannot do with interfaces, is stuff like this. You can, here I'm declaring a type. I've named my custom type alphanumeric. And what I'm saying is that alphanumeric could be a string or a number. And so if I declare a variable of type alphanumeric, I can now assign it a numeric value, and the compiler won't complain. I can declare another variable of type alphanumeric and assign it a string, and so it won't complain. And there will be cases where this actually makes sense, where you might have a variable and it could have either a string value or a numeric value, and you're stating that here. The other example down here is here I'm declaring we'll actually come back to these two examples a little bit later on. This is what's known as a union type. That symbol there is essentially the or symbol. You're saying this could be a string or a number, and you can have as many alternatives as you want to, if it makes sense, of course. This other example here is what's known as a literal type. So what we're saying here is I'm declaring a type. I'm not declaring a variable here now. I'm declaring a type. I'm saying, and that is the case for all of the examples that I've been showing you so far. I'm declaring a type called pet category. And the only values it can have are these specific strings. So here now I'm declaring a variable of that type. And so the only value that I can assign to this variable is either cat, the string dog, or the string goldfish. If I try and assign any other type of string to it with a different value, then the compiler will complain. And that can be quite a useful constraint to put on a particular variable in an application. So type aliases, anyway, are custom types that you are declaring. They begin with the keyword type, and then there's a specific syntax that you have to follow to complete the definition of that type. And again, I want to stress, all we're doing is defining the data types for our application. And then we go along and declare variables and state that they have a particular type, and that constrains what we can assign to them. Type aliases, let's see other examples. Oh, there we go. I've got a course type. No, like, I know I'm laboring the point, but I could just as well have used the interface data type syntax to declare this, but there you go. I've got an academic entity type, and I'm saying it's either of type student or of type course. And I declared student earlier on up in the, if I go back to it, I think student is here. Okay, so it's an interface, and you can mix and match interfaces and type aliases, it looks like, if it makes sense, of course. So academic entity is, this is an example of a union type. And I have an abstract function. Okay, this is the first time we've seen functions now, but I'll talk them in a little bit more detail. Here I have a function, and its first parameter is of type academic entity. So it could be a student object or a course object. Inside the function, okay, I have to, if I'm saying this thing here now, it could be, if its type is academic entity, then usually, and we know that academic entity is one thing or another, it's a student or a course, then we do have to more than likely within the body of that function narrow down, well, which type is it? Because maybe the processing that's done by this function is slightly different for a student as opposed to a course. Now, for now, anyway, the only way we can do that is what I'm doing here is I'm checking, does my entity have a particular property? Because if I look at the structure of student and course, some of the properties may be the same, but other properties will be different. And so you pick a property that isn't in the other type, if you like. So code is not an entity of student. It is an entity of course, though. So this expression is essentially saying, is it a student or a course that's been passed into me? Sorry, is it a course that has been passed into me? And if it is, then process it as a course. The else must mean that what we're processing here is a student. And I've then just got some examples where I'm invoking the method. In one case with a student X was declared earlier on, and in the second case, I'm invoking it with, it looks like a course object instance. Let's type aliases. We will come back to them. In particular, I'll talk a little bit more in more detail about these union types and these literal types. For now, let's say the focus of type aliases is this idea here. And yes, again, it does overlap with interface data types. And it doesn't really matter which one you pick. Now, type inferencing is this idea that the compiler actually works out the type of a variable for you. You see, if we had to use these type annotations, that really imposes a lot of extra work on the developer, where you essentially have to type a lot more than you would if you were implementing your application in JavaScript. Now, okay, the advantages of TypeScript are all the things that I've mentioned so far, but the fact that we have to go typing all of this extra syntax, that can be quite a burden for if you're developing a large code base. So where type inferencing comes in is the compiler itself will work out the type for a variable, essentially based on the value that you've assigned to it initially, the initial value that you've assigned to a variable. And when you assign a value to a variable whose type you have not declared, then it will impose a type on that variable. It will infer a type on that variable, and it'll hold on to that information about that variable from there on in. So, for example, here, I'm declaring a variable called a string. I'm not actually declaring its type. I'm not using the postfix annotation. But once I assign it a string to it, then the TypeScript compiler knows that the type for this variable is string. Now, what I'm showing you here is, let's go into back to VS Code. Let's go to the very top, actually. So really here, this example, I didn't have to type all that stuff. That is a perfectly valid TypeScript statement, and it's a safe TypeScript statement. By safe, I mean, we are imposing a particular type on the variable as opposed to the any type. And where you can kind of ask TypeScript to tell you what is the type of a variable. The way you do that, you can't see me now, but what I'm doing is I'm on the keyboard, I'm using the Command K, Command I keyboard sequence. Now on Windows, I think it's Control K, Control I. So if I do that now, Command K, Command I, Command K, Command I. Sorry. Command K, Command I, and it's telling me its type is string. So it has actually done that work for me. It has applied the type annotation for me, if you like. And all of the constraints still apply. So if I now, on the next line, even though I haven't explicitly stated the type for my string, TypeScript has inferred it, and I can prove that, because if I go my string equals 10, and it doesn't like it. So type inferencing is a real game changer with TypeScript. Admittedly, you will get that in other typed languages as well, other statically typed languages. So again, the keyboard sequence is Control K, Control I. If you're on Windows, on Mac, it's Command K, Command I. And it's something that you will probably find yourself using every now and again when you're immersed in some development and you're trying to work out what type a particular variable is, especially if it's a variable, let's say, that's passed around from function to function, and it will retain its type as it's being passed around, and you want to try and work out what is the type of variable by just using that keyboard sequence. It'll hint to you as to what it is. So the DS compiler can infer the type of variable based on their values, based on the value that you've assigned to it. And this type inferencing is all about trying to maximize developer productivity. In other words, you just have less physical typing to do. And this type inferencing works at the interface kind of level as well. You know, if I'm here, I'm showing you, I'm declaring here an array, looks like an array of person objects. I've declared person elsewhere, and these are valid person objects. Let's see, what am I trying to show here? Oh, yeah. Okay, let's maybe look at the source code for that. I think what you will find, and certainly what I found, is initially you may find yourself using explicitly adding the postfix annotation onto all of your variables. You may find yourself doing that initially, but then as you get a little bit more experience, you will realize I don't actually have to do it as often as I am doing it, because the compiler will work it out for me. And so maybe just to illustrate that, let's see where that is illustrated. Now, if we just take here, right, I've got a string and I've calling the character at method, which is a valid method of the string. And I'm assigning the result of character at to this variable here, but I'm not declaring this, the type of this variable. So how does the compiler know? Well, it knows that the character at method, it returns a string. It knows that, it's built into it. And so it will now tell me that the type of this guy, if I do Command K, Command I, its type is string. Equally, for here, I'm invoking the length property of my string. So that must mean that hopefully len, its type will be of type number, even though I haven't declared it explicitly. And yeah, it's worked that out for me. Now, taking it a step further, if we see this statement here, this statement here, I'm calling I've got an array of numbers. Where did I declare those? My nums was declared earlier on in this file as just an array of numbers. And I'm calling map on that. You remember the map function, and I'm passing it a callback. Now, I'm not saying here what type num is, but because this is an array of numbers, then num here must be a variable of type num. And it's the type inferencing of TypeScript's compiler that actually works that out for me. Again, to prove it, Command K, Command I. Yeah, its type is number. And to take it a step further, looks like the callback is returning a number. It's just doing some sort of arithmetic operation. And so that means that this array here, or sorry, this variable here, it's going to be an array of numbers based on the callback that I passed to map. And I'm not explicitly declaring the type, but type inferencing works it out for me. Command K, Command I. Okay, got there eventually. It's a number array. Again, that's all type inferencing. And, you know, as I was saying there, alluding to a while ago, initially you might find yourself explicitly stating that here, and there's no problem. You know, you might find yourself adding on the the actual annotation for all of your variables, even though you don't have to. But that's only something that you kind of pick up as you go on. Well, okay, this is just another example of type inferencing. You know, I'm declaring my array of person objects. I'm invoking the filter method on my array of person objects. And you remember filter from last year. So filter will return a subset of this array, but because this is an array of person objects, that must mean that this here is also an array of person objects. And, you know, to prove it, we get that. Moving on, let's talk a little bit about functions. I've made one reference to them already, but with functions, you have to apply typing to both to the parameters of a function and to the return value of a function. You have to state either explicitly or have it inferred. Of course, you've got to be careful. You've got to be careful with inferencing that it's inferring the type that you expect it to. You know, if it's inferring a type that you didn't expect, then that's usually because you've actually done something incorrect along the way. So it's also a check that the code is as you think it should be. But staying with functions, so for functions, you need to impose types on the parameters, and you also need to be explicit about the return value. And so the syntax, if we want to be explicit about it, is the syntax looks like this. So I've got a function here called addNumber. It takes two parameters, both happen to be of type number. And this part over here, so after the closing parentheses, you use this postfix annotation again. And here I'm declaring that the return type, in this case, is number. And so if within the body of this function, we try and return, let's say, a string or a person object, if we do that within the body of the code, then you will get a compiler error straight away telling you that there is an inconsistency between what you've stated up here and what you are explicitly returning in the body of your function. And clearly, you know, it wouldn't make sense that you would be returning something other than what you've stated. So you've made some miscalculation in your implementation of the function. Can I just go back to when I was introducing the types, the basic types of the language, I said that it had primitive types, and we've seen lots of examples of that. It has object types, that includes classes, modules, etc. It obviously has these various custom data types that you can define, but I also mentioned the any type. If a variable's type is the any type, essentially you're back in kind of the JavaScript world. And I can illustrate that to you, even though what we say is that you should try and avoid almost entirely having any variables whose type is the any type. There really shouldn't be any need to have a variable whose type is the any type. But just to show you an example of what I mean by that, if I declare a variable called foo, and let's say I don't initialize it. If I now if I ask the compiler using Command K, Command I, what type is this variable? And it's telling me it's the any type. What that means is I can now assign any value to that variable. I can assign it a primitive, I can assign it a person object, I can assign it a student object. It's not going to complain. And I can change its assignment from one type to another. So I could assign it a string on one line, and on the very next line, I could assign it a person object. The compiler is not going to complain because I've stated up here that, or it is inferred. I could be explicit about it. I could say explicitly that its type is the any type. And everything that I just said there a moment ago applies. But you should never really resort to having variables that are of the any type. But that's where it comes from. Okay, back to functions. Inferencing can be very useful, really, when it comes to functions. So the compiler can infer. It can certainly infer the return type of a function by simply looking at your code, looking at the return statement within the body of a function. It'll work out what type is the thing that you are returning, and then it will apply that to the function signature. Right. So, for example, here I've got my add number array function, and it looks like I'm passing it. Its first parameter is an array of numbers. Second parameter is a number. And okay, I'm being explicit here. That's not really illustrating it, is it? Oh yeah, sorry, beg your pardon. You can see here, I'm not actually explicitly stating the return type of this function, but in the body, based on what I'm doing in the function, okay, I'm invoking the map on the array of numbers that have been passed into me, etc., etc. I'm returning this new nums. New nums here is going to be an array of numbers. It will infer that based on the kind of discussion we had earlier on. So I'm explicitly returning an array of numbers. And what I'm showing you up here is when I do command K, command I on this function, it has worked out that, or it has inferred that the function's return type is an array of numbers, even though I haven't stated it explicitly here at all. So type inferencing is doing its thing there as well. Now, if I go back to my code, I've got a separate folder. Now, by the way, I haven't ran anything yet, but if I want to, let's first undo any changes, sorry. I did want to run this script that I've been looking at, which is this one here. Then based on what I'm told in the README, this is the command that I use. Sorry, this is the command that I use. Then give the path name. Now, because it's index.ts, then it'll pick it up automatically. I could be explicit about it if I want to. And what this is doing, as I said there earlier on, what this command is doing is it's taking your TypeScript file, it's compiling it on the fly, and it's running the output of that compilation, which is JavaScript. It's running it on the Node platform. And so I get, this is the various console.logs. If you do want to compile it and see the output of the compilation, in other words, you want to see the actual JavaScript, there are very few cases where you might want to do that, but this is the command to generate the actual TypeScript physical file, because you don't see the generate the physical JavaScript file. So if I just do that, just to show you what it looks like. And up here, we can now see that there is an index.js file. and that's the JavaScript equivalent of my code. And the thing is, and even people that have been using TypeScript for a while, sometimes they kind of forget there's no evidence at all of any data types in your JavaScript code. So essentially kind of the raw JavaScript that's generated has no type safety in it. The type safety is only available to you at compile time. So if I made some edits, which I should never really do, but if I edited this file now and violated one of my variables, okay, structure, and ran that code, then, you know, it's still going to crash as a result of me violating a particular data types structure in my JavaScript code. This JavaScript code, we would just run using the ordinary node command. Although there is a trick that you have to do, which you shouldn't have to do, but if I want to run this JavaScript file using the node command, as in going node, because it is just ordinary JavaScript in a sense. It's going to throw an error, and I don't want to get into the detail of what that error relates to. The way I can actually fix it is if I go into my package.json and just remove this line here. I know I'm not explaining why now, I'm just doing things, but if I just remove that line, save that, and then try and run it, I think it's going to run okay. Okay, it runs okay now. And it's giving me, you can see there, even though we haven't looked at the detail, but it's giving me the exact same output as I got when I ran my TypeScript earlier on. But there's no real need, certainly in terms of what we'll do in this module. We'll never really need to look at the raw JavaScript that's produced by the compiler. There certainly are cases where you would need to do that in a professional environment, but not in our case. Now, if you do that, make sure you go back to your package.json and undo the change, because if you don't undo the change, you're going to start getting problems with your TypeScript. So you can undo that and save it. Okay, functions. Don't know why there's a gap there, but that's a typo, obviously. So in a separate source folder, I've got some examples of function-related stuff. Now I've got a couple of files here. Let's just look at the index.ts one. And we've probably seen this already, so do I need to go over that again? I don't think so. Oh yeah, I'm using the function declaration syntax of JavaScript here, but of course, we mainly use arrow functions now. We don't tend to use that older syntax as much anyway. And if you want to declare a function using the arrow syntax, then okay, the typing is it's not that tricky, I suppose. So here I'm declaring using the arrow style and declaring a function. That's the function name. Here's the parameters and their types and the return type, and that's all straightforward enough, I think. I've got my arrow, and then I've got the body of the function, which in this case happens to be just single statement. Inferencing, just to an overdo, but I don't really need to say that the return type here is string. It will infer that from the return value. Again, you know, Command K, Command I. The way sorry now. Oh yeah. The way it's telling you is slightly different. So it's actually putting the return type here after the arrow. We'll see actually why that's the case. We'll find ourselves using this as a way of declaring a function's signature. But this is essentially, this is the TypeScript compiler's way of expressing the signature of this arrow function. Parameters are of type string, return type is of type string. So it has inferred properly for me. And, you know, the parameters can be, okay, they're primitives in this case, but obviously they can be complex types, or it can be of any type, really. In this example here, sometimes you will have functions that don't return anything. And in that case, what we say in the TypeScript world is that the function's return type is the void type. And I'm stating that explicitly over here. And again, I'd say if I got rid of that, it would infer that anyway. Sometimes you're better off being explicit about your typing. You know, don't let TypeScript infer everything for you. By that I mean, for other people reading your code, it might be easier for them to read your code when you are explicit about the types associated with variables and function signatures, etc., etc. But let's just see, does it actually work out if I remove it? Yeah, it's worked it out for me. Now, I could ask a question, but let's see. Why isn't the let's see now. How come the return type of this guy here is string and not void? I don't have any return statement here, just as I don't have any return statement here. Now, my question actually isn't really a TypeScript question. It's a question about JavaScript and arrow functions. I don't know, can people remember what the explanation, why I'm not being explicit here about a return, but still it's working out that the return type is string. It's not saying the return type is void. Can anybody offer an explanation as to why that's the case? The answer is I'm using the shorthand form of the arrow syntax. Notice here, I don't have any opening parentheses and closing parentheses in the body of my function, whereas down here, I have an opening parenthesis, sorry, not parentheses, curly brace. I have an opening curly brace indicating the start of my body of my function, and this closing curly bracket is the end of my function body, whereas up here, I don't have those curly brackets at all. And the shorthand form of the arrow function is, if you leave out the curly brackets, then it assumes that the body of your function comprises of one statement, which it does in this case, it's just that statement. And that statement, the value as a result of executing that statement, that is the return value of the arrow function. That only applies if you don't actually wrap the body of your single statement arrow function, if you do not wrap them in curly braces. Another way of putting it is, if I got rid of that and got rid of this, I'm now going to get that the return value of this function is whatever console.log return value is, whatever the log method of the console object returns. I actually don't know. I think it might be void as well, coincidentally. If I do Command K, Command I. Oh yeah, you can see there, right? Log returns a void. So that's just coincidental that it is actually void. It is what it was when I did have the curly braces in there. Anyway, that's an aside. That's not really a TypeScript thing. That's more a JavaScript arrow functions and shorthand version of arrow functions. That's all that's going on there. Moving on. Let's see. Okay. This Command K, Command I can be useful as well. Sometimes it can help you as a developer to work out the return type. Now I'll come back to the whole area of promises later on, but if you see this function here, and I'm using the promises syntax in it, so it looks like that this function is actually returning a promise. And based on how I'm resolving the promise, I'm resolving it with a string. You might wonder, I wonder what is the return type of this, because I'm not explicitly stating the return type at all here, right? And so if I ask the compiler, essentially, can you tell me what is the return type of this function? So let's do that. Command K, Command I. And it's actually telling me that its return type is a promise where the nature of the promise that's being returned is a string. And that's actually correct, because here when I'm resolving the promise, I'm actually passing a string to the resolve method as opposed to anything else. So its return type is a promise of a string, if you like. Here's another example of that, where I'm using the promise. I'll come back to promises later on because they're actually going to be quite important in our discussion on distributed systems. But in this case, I'm explicitly resolving. See what I'm doing here? First of all, I'm not stating what the return type. I'm not explicitly stating the return type of this function. Okay, I'm not saying anything here about the return type. Oh, sorry. I am explicitly stating it, sorry. I'm explicitly stating the return type here, but if I actually took that out, could it work it out for me? Let's see. Command K, Command I. Yeah, it's actually inferred it, so I didn't have to be explicit there. And so you can see how this inferencing is both useful and quite intelligent. And you can see in terms of how it resolved it, I created an object of type person here. And then in my promise.resolve, I'm returning that object. And so that enabled it to work out the fact that it's a promise of a person is the return type of this function. Okay, so the 101 of functions is you have to declare the types of your parameters and possibly the return type as well of the function. When it comes to higher order functions, you might remember that a higher order function is a function that takes another function as one of its parameters, and that function parameter we refer to as a callback. So the question arises is, how do we express the fact that a parameter is a function as opposed to a primitive or an object? And there is a syntax available to us in the language. We've actually seen it already in passing, but here's an example of it. So it's an abstract example. I've got this function called print to console. It takes a string as its first parameter, and this parameter here is meant to be a function or a callback. And here's how I'm expressing the type of that parameter. And this is saying, well, callback is going to be a function where the function takes one parameter, its type is string, and its return type is also a string. So this is how you express the type for a function. You use the actual arrow symbol in the syntax itself. Here's another example. I've got a function called array mutator. It takes an array of numbers as its first parameter, and the second parameter, in this case, also happens to be a function. And in this case, the function has to honor this signature here. The function's parameter list comprises of one parameter, and its return type has to be a number. And so when you are actually using this array mutator, when you're invoking it, the compiler will check to make sure that the function, which is the second parameter that you pass to the invocation of array mutator, it will check that the function, the callback function that you're passing to it, does actually respect this statement that you're making here as to the type associated with that function. So the function signature syntax, I'm saying this function syntax can be used in type aliases as well. Remember, type aliases, I mentioned there a while back, type aliases overlapped with interface data types, but you can use type aliases for other things as well. And here's another use case for type aliases. When you want to declare a type and associate it with that type a function's signature. So let's see some examples of that. It does actually get quite tricky, I'll be honest, when you start using these higher order functions and declaring the type of the callback associated with your higher order function. So here's sorry, just before I do that, if I go back to here. Oh yeah, I just overlooked that. This slide here, I'm doing an import statement. I'm importing person from a file called mytypes. And here's the mytypes file. This is the first example of a declaration file, as we call them in the language. In the files with the .d.ts extension, what you put in there, if we look at it, are declarations of custom types associated with your code base. And so there will only be interface data types, type aliases. That's all that really should appear inside a .d.ts file. And so I've got a friend type, I've got a person type, and so on and so forth. And I'm exporting, you will be exporting all of these. And so I'm just importing the person type in that source code that I showed you there a moment ago. You don't need to add on the .d in the import statement. It will work that out for you. Okay, back to higher order functions and return type. Here I'm invoking that function. The first parameter is a string. That's consistent with what I'm saying here. The second parameter is this here. Okay, it is a function. Sorry, I collapsed that by accident. It is a function. And if you look at the signature of the function in terms of its parameters and the return type, they are all consistent with what I'm saying up here. And, if you violate it, so if you violate that signature, then, if I return, let's say, a number, or if I return a Boolean, then certainly complaining, looks like. And if I look at my problems, and if you read the explanation. It's saying that the argument of type string Boolean is not assignable to the property of type string, function string, and returning string. Here I'm using, up here, I'm using an anonymous function in my invocation, whereas in this example down here, I'm just declaring, let's see, where is it? Okay, I'm just declaring a function, and that's the function name, and I'm just passing that function as my callback to this array mutator. But again, that function, this one here, its signature has to respect what I'm saying up here. And if you check it, you'll see that it is. Now, this kind of syntax here, you know, it can get quite messy. This explicitly declaring the callback's signature and inlining that in your function declaration. An alternative approach is to what I've highlighted here. If I assign what I've highlighted to an actual type declaration and then give that type declaration a name and then use that name or substitute that name with what I've actually put here. So that's what I'm doing down here. I'm declaring using the type alias syntax and declaring a variable called mutation function. And I'm assigning it, you know, the syntax for a function signature. And now I can use that I was going to say variable name. I can use that type name here for declaring the type of my callback. So it's just slightly more readable code. And certainly if I was reusing this in multiple places in my code base, then rather than having to type that or cut and paste it all over the place, I can just use the alias for that signature instead, and it just lends to arguably more readable code. So that's where these type aliases really can shine. Now, I'm not saying necessarily you're going to be doing a heck of a lot of that. I may well be teaching you more TypeScript than you will need to use in this module, but you will be reading TypeScript and see this stuff going on. So being able to interpret it is much part of my objective here as anything else. Right, that's higher order functions. I'll just cover optionals and then I'll leave it at that for today. Now, up to now, when I was talking about interface data types and their equivalent in type aliases, every property of the object every property of the object structure that I was declaring were mandatory. But in the real world, you may have cases where a structure of an object, some of its properties may be optional. In other words, you may need to use them in one instance, but not in another instance of that particular object type. And this is where optionals come in. And we use the question mark to state that a particular property is optional within the structure. So here we go back to our interface, and I could have used type aliases here as well. I've got an interface data type called user. And what I'm saying is that the email property is an optional property. So it would be valid to create an instance of a user object that does not have email as one of its properties. If I took away the question mark there, then every user has to have an email. In the case of the social property, I'm saying the social property is also optional. I'm saying that the social property, if it's present, is an object. where the structure is like this. And some of the properties within that nested object, some of them are optional, and this one isn't. And status is mandatory. So your optional properties can be anywhere within the structure. And this optional question mark symbol can be used with functions as well. You can declare parameters of functions as being optional. Mind you, the constraint is you can only have optional parameters at the end of your parameter list. In other words, you can't have, for example, you can't have the case where the first parameter is mandatory, the second parameter is optional, the third parameter is mandatory. It won't allow that. Optional parameters of functions can only be at the tail end of the parameter list. But sticking with the use of optionals in relation to data structure types, if we look at go back to our source code, you'll see some examples of them in there. So we now move into the optionals folder. Okay, here's the user one that I talked about. And so here I'm creating an instance of user, and looks like this person doesn't have email. That's okay because it's optional. They do have a social property, and if they have a social property according to the interface type, they must have a Facebook property, and that's actually the case. And again, what you may not be getting from here now is, how the TypeScript compiler kind of helps you as you're typing your code. So if I want to add some more properties and I can't remember what are the other properties, it'll start hinting to me straight away. So if I just type T, then it's telling me, this is the property you're looking for. So it's getting that for you. Usually the interface type would be declared in a separate .d.ts file. And so rather than having to flick back and forth between those files, if you've got a reasonable guess at some property, once you start typing, the compiler will help you to complete it. And the same constraints apply. You can't put properties in that don't exist. You are saying here that these properties are certain properties are optional, but they have to, they have to be exactly named like that. And other examples of user objects, some of which are omitting the optional properties, which you can look at yourselves. In relation to parameters, the syntax is, you can see here that the last property, this one here, is we're saying it's optional. So I can have an invocation of this where I'm passing it 2 parameters in one case, which I am here, and 3 parameters in another case, which I am here. If I take away, obviously, I suppose the statement of the obvious, but if I take away the optional characteristic there, then straight away it's going to complain because I'm now only passing 2 parameters, and that's not adherent to my signature. And there's some more examples that you can look at in the rest of this file yourselves. Don't think I need to talk over them. Literal types, I won't cover that today. Now, if I go back to the lab, based on how far I've got, let's go into the lab. Well, you can kind of tell from the section headings, you'll now be able to do everything. You'll be able to do the interface data type section, the TS functions section, the optional section, the type aliases. You may or may not, you can see yourselves whether I've covered the material or not. You certainly won't be able to use I'll get into the generic section you won't be able to cover the utility types section. So you'll only be able to get that far until this far here, potentially until next week's lecture. And in terms of handing up or the kind of closing date for all of that, I can only guess at that now at this stage. I'll give you a more a firmer date next week when I've completed this stuff. Okay.